Chapter 18, Part 2, Visibility. With the first three principles taken care of, we can now focus on the remaining two mechanisms which concern visibility, line of sight and reduced drawing. The reduced drawing mechanism would involve drawing the nearby dungeon parts more clearly than the far parts, either by not drawing the far parts or by drawing them indistinctly. Furthermore, we would only draw those distant parts we had earlier visited. We can achieve this with two mechanisms. We'll remember which cells we have seen by setting a Boolean flag lit to true in them. All cells will start out with a falsy value, either false or undefined. This provides us with the visited status. We'll determine near and far by measuring the distance between the player and the given cell. Whenever that distance exceeds our far threshold number, that cell is deemed to be far. This provides us the near-far status. So, in the 07 map cell, we add the Boolean lit property. And then in the map drawing, we make an updated map drawer that has parts that look like this. The full version, the draw map 18, will look like this. Proper visibility criteria. We've achieved only draw near with the crude distance threshold mechanism. There's a more proper and traditional mechanism commonly referred to as field of view, FOV. It's based on line of sight checks in a radius around the player, starting from the player's point of view. There are known solutions to do this, and we may present such mechanisms in a later chapter. For now, however, we have demonstrated that a basic, similar but much cruder effect can be achieved with far simpler means. Note that such a proper field of view mechanism will behave like a sort of flickering torchlight visual effects, which may be perceived as either pleasing or annoying, depending on who you ask. In the meantime, we can add a check for whether monsters can see each other. What does see actually mean here? Well, if there's a brick wall between us, we can't see each other, so we want an unobstructed line of sight between the two creatures. It's also just called a line of sight, or LOS for short. How can we check that? One approach is to attempt to draw a conceptual pixel line of map tiles between the two creature positions. Then we check whether each of those map tiles is see-through or not. The definition of see-through is, again, up to us. We have some leeway or choice here. We'll consider a wall or rock tile to not be see-through. We'll, on the other hand, consider empty floor tiles with objects, and floor tiles with monsters on them to all be see-through. In conclusion, our choice boils down to that walls and closed doors are not see-through. However, you could of course make a game with any weird combination here. Drawing a correct pixel line is not insanely difficult, but it's not trivial either. Luckily for us, a conscientious man named Bressenham did the work for us many decades ago, and he distilled it into his simple and elegant line drawing algorithm. You can see it below in our Bressenham iterated.ts file. We have implemented it in a sneaky way, namely as an iterator. This allows us to reuse it whenever we need something that involves a line between 2 points. For example, if we had other spells that would shoot a line of ice at a target or melt a tunnel through the rock. We'll express our tile see-through check as the method opaque. That is, the opposite, not see-through. We already have a similar check called blocked. Beware that they are not quite the same. A tile may be blocked, even though it is still see-through. If a cell is blocked by a monster, we still consider it see-through. Similarly, we could have an impassable barred window, which would still be see-through, allowing the player to see whether there is treasure or other items or creatures of interest on the other side. Line of sight, Our line-of-sight mechanism requires an implementation of Bresenham's line drawing algorithm. So we make and present the Bresenham iterator.ts file, which looks like this. The idea with this Bresenham iterator is that you supply it with 2 points, P1 and P2, that you wish to draw a line between. You can then use it to loop through the series of points lying on the line between the 2 points. Iterate all 1 and iterate all 2 shows 2 or 3 ways to do this. They all boil down to calling next and done in a loop. Done stops once you reach point 2. One way involves that the Bresenham iterator collects all visited points in the pixels vector. This lets you approach the line as a full set of points, instead of approaching it like an iteration loop. You can call iterate all 1 if you want to do it this way. If you instead write your own sequential loop similar to those in iter all 2, you can achieve things like tracing along the line path until a certain condition is met. For example, that you hit or find a certain target, or collide with, for example, a wall blocking your shooting path. We'll use the latter approach to test line of sight between 2 creatures. We make this utility class 24canC. We can now use this in 2 places. We can change the AI so it only chases enemies it can see, and we can change the map drawing function so it only draws monsters that are visible to the player. The updated cloned as Sleep 2 AI will contain this variant of turn. And the updated drawing mechanism, which only draws line-of-sight visible monsters, will have its inner loop looking like this. The important bit with CMob has this logic. If there is a mob and we are near to that mob, close to that mob, only then will we calculate the canC check, because doing so is expensive. In this way, even though the dungeon map might contain 200 monsters, we'll only do this calculation for maybe 10 of those monsters which are inside a near radius circle. Draw map player must be changed to use our new draw map 18. If you try to run index 18 bats again, you should now only see a nearby circle around the player drawn clearly. And inside that circle, only those mobs which are directly visible to the player, without wall obstacles in between, should be drawn. Outside the near circle, only earlier visited parts should be drawn faintly blue.